What's going on, everybody? Johnny Bannon here, the networking guru, and in today's video, we're going to continue on domain 1.1 of our CySA full and free full course. So in this video, we're going to focus on identity access management. So part of AAA, authentication, authorization, and accounting, we're going to go over all the different things that we should cover with IAM. So with that being said, let me go ahead and get my face out of the way, and let's get started. Okay, so we're going to be going over domain 1.1.3, explain the importance of system and network architecture concepts in security operations. So always keeping that in mind as a SOC analyst course, as I like to look at it, identity and access management. So as a SOC analyst, what do we need to be aware of and what is important in our day-to-day duties or roles? So in this section, we're going to be going over identity and access management and all these subdomains. So first, we're going to touch on MFA and then get into single sign-on and federation, which is pretty similar. We're going to dive a little deeper into that. Go over PAM, passwordless authentication, which is, I wouldn't say new, but it's becoming more adopted in major enterprises. And then lastly, we're going to touch on CASB, do our quiz, and then we'll be one more video down from domain 1. IAM introduction. So identity and access management is a critical component of security operations. It focuses on ensuring that only authorized individuals and systems, and also service accounts and other subjects, can access specific resources in our enterprise. When we implement these IAM solutions, organizations, service providers, identity providers can control access to what and how access is granted. So they can control who has access to what, how access is granted, and how it is managed over time. So in this lesson, we're really talking about AAA. That's authentication, authorization, and accounting, and then also IAM. Now, IAM and identities, authorization, accounting, authentication has always been a major, what I like to call like a perimeter in our security operations. We look at our defense in depth and our onion layer of security. In traditional networking, it was always, let's filter the network traffic and let's monitor vulnerabilities and scans. But always when you hear a data breach, it's an account. Now, not always, obviously, I'm being exaggerated for the sake of this lesson, but some account got compromised due to a phishing attack or credential harvesting attack, credential replay attack, whatever the case may be, it was somebody's credentials that got stolen and used or exploited, and it was maybe a regular user, and then that hacker was able to do privilege escalation. So IAM is very important, and it's always going to be one of the major concerns from a security perspective. So when we're in our SOC and we're going to our weekly stand-ups and we're going over our log dives, our current vulnerability scans, what's on the agenda if we're doing log dives, IAM is always going to be a big part of that. So now let's get into different things and how we can protect our identity and access management. And not only that, but with the cloud, with these large enterprises now that are more hybrid. When I mean by large, I mean it's not just in one office building anymore we have to worry about. We have cloud-based resources that users access. We have remote workers that are on the internet on the regular machines and then accessing corporate resources in our intranet and then also the cloud. We have a threat landscape that is much larger than a lot of our predecessors doing cybersecurity back in 2000s, if there was even cybersecurity professionals. There was, but anyways, before I go on a tangent here, all this to say that IAM, in my opinion, is becoming one of the major computing factors. And what I mean by that is typically we look at like a data center, enterprise resources. You have storage, compute, and network resources that we manage. And I believe IAM is becoming one of those big resources that we manage and have to be aware of and have experts in. And your role as a SOC analyst is to enforce these policies, to enforce standards, to enforce that zero trust kind of principles using RBAC, principle of least privilege, enforcing multi-factor authentication, having good contextual awareness, and having good auditing. And if we're using third-party services, identity providers, using strong encryption and strong methods to authenticate. Now let's actually get into it now. Spiel over. So multi-factor authentication. You have probably used, even as a regular non-tech person, have more than likely used multi-factor authentication either in your personal life or in the corporate arena. So multi-factor authentication is a method of verifying a user's identity by requiring 2 or more forms of authentication before granting access to a system. In the real world, I have this for my regular Gmail. When I want to sign into Google, I put a username, I put a password. That's one way of authenticating me. And Google's authentication server saying, yes, that username and password is correct, but I need something else. Because that can be stolen. Those credentials can be taken. Someone could guess them. Maybe my passwords aren't that strong, and someone can steal that credential. So I always enforce two-factor authentication even in my personal accounts. So what is that? So the 3 factors that can be used in multi-factor authentication are broken down into 3 major ones. That is something you know, something that you created, something that you typed up that's in your head. So that's a password, a PIN, a passphrase, and username, credentials. It's your ID that you type in. So that's something you know. The other major factor is something you have. This is something physical, something in your possession. So that's your cell phone sending you a code. That's your cell phone doing a push notification on a app you have downloaded that you need Face ID to access, or a PIN to then say, yes, that is me signing into this computer. It's something in your possession. This could be a smart card. In the government, we have common access cards that are used to plug into computers. They have an X.509 digital certificate on it that correlates to our user accounts, and we have to plug that into a smart card or CAC reader to be able to authenticate onto our domain computers. The other major factor is something you are. This is going to be your biology. So this is going to be biometric data that's used to identify you. This is fingerprints, facial recognition, eye scans like retinal or iris scans. The combination of any 3 of these is considered multi-factor authentication. Sometimes you hear this being like 2-factor, second factor, 3-factor. This should just be the standard. This should also be used when we're doing something like contextual awareness. So let me paint a picture for you. If you travel to Europe and you don't warn your bank and you swipe that credit card for a nice Italian dinner, what's going to happen? They're blocking that transaction. Your card's blocked, and you got a hassle on your hands if you got to call them because they say, hey, your phone is also in that location, so we're not accepting app verification that was you who swiped your card in Europe on that nice Italian dinner. Why am I bringing this up? Banks have been doing contextual awareness for a while. If something is out of the ordinary for one of their users, they're going to block their cards. It's a safety mechanism. In the cloud, in our enterprises, we can now do that as well. We can have some sort of feature or machine learning or some sort of plugin that's doing privileged identity management that has contextual awareness set up. So that if we have sketchy logins, risky logins more the official term, not sketchy logins, but if we have a risky login, meaning we notice a user is trying to log in at 2 in the morning from Washington when they live in North Carolina, typically we may only request a username and password, but we may have it built into whatever authentication service is to enforce a second factor based off some contextual awareness, saying, hey, this looks like a risky login. They're logging in at a weird time, which is an anomaly to their typical baseline behavior, or they're trying to log in from a location we don't recognize. So multi-factor authentication should be the standard and the baseline, but it should also be enforced based on some risky login behavior, contextual awareness. So to sum it up, by combining multi-factors, MFA significantly reduces the risk of unauthorized access, even if one factor, like your password and username, is compromised. Okay, moving on. Single sign-on. So you hear this a lot. SSO, integrate SSO, single sign-on. This is a way to use a single credential to access multiple different services and applications within an organization, a domain, or a website. So I have this book up here. When you read the official CySA material, you look this up on Google, you ask ChatGPT. When you are using Google to sign into multiple websites, that may feel like a single sign-on experience. And for the layman, it is. But that's actually called shared authentication. Single sign-on is a little bit more specific. Think of when you go to your job and you log into your corporate computer. From an IT perspective, I call that logging into your domain joined computer. Meaning you're logging into a computer that's already in maybe my Active Directory forest. And when you sign in with your credentials, you now get access to our Office 365. You get access to our OneNote, our SharePoint portal, and a shared drive based off that credential that you use to log into that computer. So based off that one credential, you're getting access to all these applications. But here's the thing. With a single sign-on experience, you only sign in one time. You sign into that computer, and then you get access to all those resources without having to sign in again. That more accurately describes SSO. So SSO centralizes the authentication process for a bunch of different apps that you should be granted access to based off that single authentication. So SSO, this relies on a centralized IDP or identity provider. In this picture here, I have an LDAP server. LDAP, the Lightweight Directory Access Protocol, is used for Active Directory. That's going to be the most common one we see in on-prem enterprise domain services and authentication IAM. So, back to it, SSO relies on a central identity provider to handle authentication. When a user logins to the IDP, they are issued a secure token. This token allows them to access other connected applications without needing to log in again. So there is the more accurate definition. So another protocol they could use is like SAML, but LDAP is an example I have in there as well. So, like I said, we don't have to read this example down here. They can access email, file storage, and project management tools without needing to log in again. Now, shared authentication. This is going to be when we use another IDP like Google, like Facebook, like LinkedIn to access third-party websites. But if I'm using Google to access trepatech.com, example.com, example2.com, guess what? I'm still having to sign in with my Google account. Even if I'm doing it from my Chrome web browser that's already signed into my profile, I'm logging in again. That is called shared authentication using an identity provider. And more accurately, that's called decentralized authentication identity providers. Anyways, now let's get into another term that's kind of also what I'm describing, called federation. So federation extends this concept. It extends the concept of SSO by enabling authentication across different organizations or domains. So federation comes in many different ways. We can configure federation using different protocols like OAuth, SAML, OpenID, Active Directory Federation Services. That's the four major ones that allow you to have what's called a relying party or service provider. They have that backdoor, not a backdoor, but they have that already established trust between an IDP, and when you try to access that relying party or that service provider, they're going to use one of those federation services or protocols like OpenID or OAuth 2.0. They're going to use that as communication to an identity provider to verify you are who you say you are, and then grant you access to that relying party, and then that relying party is going to set permissions for you. So if you bought our CYSA course on trepatech.com, there's an option to sign in with Google. This is federation. This is that shared authentication service. It does feel like a single sign-on experience because you don't have to create a new account. You can just use an account you already have. But more accurately, this is called federation. So federation relies on trust relationships that are already previously established between identity providers in different domains. Identity providers and the relying party or the service provider. So we can see a quick example up here. This user is trying to sign into example.com or any of these example.coms. So they access this cloud portal. Let's just say call it a cloud portal, okay? The user's browser is going to redirect them to an OpenID provider. So in this federation example, we're using OpenID, but this same process can be done with Active Directory Federated Services, OAuth 2.0. Okay, so just OpenID example here, but it gets the point across. When we go to log in, we're going to hit sign in with Google because that's what I want to use here, this Google. And I put api.google.com here because this trust relationship is going to be, you're going to have to send an API request. Anyways, that's going to redirect you to your Google sign-in. It's really small right there, but I took a screenshot of the Google sign-in. You're going to authenticate against this IDP. That IDP is then going to create a JWT. Now, this is an OpenID example. Look at this as just a token. SAML does it. They create a token called a SAML token. Anyways, but a JWT in this example of OpenID is a JSON web token. It's a secure way to send across the web that, hey, this person is who they say they are for our authentication. So once we authenticate to that IDP, after being redirected from our relying party or our service provider, they're going to send that JSON web token back down to us. That token is then sent back to the relying party, and then that token is validated and you're granted access. And then OpenID will allow authorization, but that's not always the case. This is straight up authentication, right? Then we set permissions from there as the relying party of what you can and cannot have access to. So that is federation. And hopefully that kind of clears up the difference between this and SSO. I know when I first started learning this, I always would get confused, like, why isn't this a single sign-on experience? To the layman, like, oh yeah, integrate Google so we can give our users a single sign-on. That may be what we say at the meeting table, working with developers and our stakeholders and the marketing team. But on the tech side, we want to be very accurate in our definitions. That's federation. Okay, moving on. So now let's go over privileged access management. So privileged access management kind of differs from everything we just learned about. And this is not concerned about how we authenticate. This is not concerned about the technologies used in authentication. This isn't concerned about single sign-on or federation. All privileged access management does is it allows us to have a simplified way to monitor different service accounts, privileged accounts, application accounts, and user accounts, and what they're doing on our enterprise. So privileged access management focuses on controlling and monitoring access to accounts with elevated privileges. So for an example, let's say we have multiple different help desk admins that need to do account unlocks, resets, whatever the case may be. So we get all those admins and we say, hey, you're going to use this service account that has elevated privileges called helpdesk@example.com. And if we have a PAM system installed, our PAM system is going to let us be aware and monitor which help desk technician is using that account to unlock other users' accounts. So it's more or less credential management. It lets us monitor that. So we could have Bob the admin that uses a shared admin account to edit some network configs and a shared admin account to change some settings in the cloud. Then we're going to have Alice the admin over here do the same thing, but with our PAM system, it's going to allow us to say, hey, we see that helpdesk@example.com reset a password that wasn't supposed to be reset for an already offboarded employee. So we have an incident on our hands. Well, that could be a problem if we didn't have privileged access management. Privileged access management lets us monitor. So now you may be asking, well, why not just give every single admin or every single help desk technician or IT professional their own admin account? Privilege creep. Because maybe we don't want to have that burden of managing all that. Maybe if it's easier for us to just manage these specific service accounts to do the job that they need to do, it helps us with our principle of least privilege and gives us still that ability to have some sort of accounting and auditing log. So before we move on, some key features of PAM. Credential management. PAM securely stores and rotates credentials for privileged accounts to reduce the risk of exposure. So it can also do that, another key feature. Session monitoring. PAM tools record privileged sessions for auditing purposes, ensuring accountability. Like we already described, we could have 10 help desk techs that use helpdesk@example.com for password resets, and we can see who did what. And then access controls. PAM enforces the principle of least privilege, ensuring users only have access to what they need to perform their task. And this is a good way to do it in a large enterprise. If a help desk technician has to make a change on a switch because one of our NOC analyst ones isn't there, maybe we can use PAM to give them, just-in-time permissions or something like that. Say, hey, on your user account, we're going to give you 8 hours to perform this task, and it's going to go away. We can do that from our PAM software, and that lets us, control what's called privilege creep. Oh, sorry, skipped a little too fast. Passwordless authentication. So this is kind of I wouldn't say it's brand new. Some companies are using this as a way to protect against like phishing attacks from exploited credentials. So passwordless authentication, it's in the name. Users are no longer having just a username and password. They're going to have a username, an identity, whatever that may be, plus a second factor to log in without the need for a password. This helps in that now a user doesn't have to worry about password rotations, making new passwords, and the folly of what humans will typically do in making their lives easier by setting easy passwords. And then if we went the opposite way and we said, well, we're going to make them do 24-character passwords, then you get users complaining. Users complain, that goes up, and then it rolls downhill. I don't want to cuss because these are professional videos, but the rolls downhill, and all of a sudden the cyber team, the system administrator team is hearing from some C-suite level stakeholders saying, why is it so hard for me to reset my password? Why are we rotating it every 30 days? So maybe the solution is, here's this YubiKey. This is your password now. keep it on you. I have your spare locked away in this drawer that's locked up that only us and a few admins have access to in case you lose it, but don't tell the user that. Set your username, and this YubiKey, something you have in your possession, is now going to be the way you log into our systems. So it kind of gets rid of the password issue, to say. So some common methods of passwordless authentication: biometric, hardware tokens, magic link. So this is just getting sent a code, getting sent a link to your phone or your email. Push notifications as well through a mobile app, which kind of in and of itself is multi-factor because you have to put in a PIN or a Face ID and then hit the app, right? So you get a couple additional factors along with that when using the phone. Sorry, I keep skipping ahead. Now, last thing we're going to go over is CAS or CASB, a cloud access security broker. Think of this almost like the man in the middle that can monitor and enforce policy from your on-prem organization to your cloud resources. This image I got from it in the link description below. It'll show you what website I got this from, but this kind of shows it perfect. So you can have direct-to-cloud connections, but if you have a CASB in the middle, this can do a couple things for you. This can redirect the users, almost acting like a proxy, but it's going to give you visibility. It's going to give you maybe some enforcement policies, some data loss protection from users trying to send something to the cloud that maybe they shouldn't be. You get threat protection. It can detect and mitigate threats like malware, unauthorized access between your perimeter, your intranet enterprise, to your cloud-based resources. It could also help in compliance. So maybe this is an easy way for you to get compliant with GDPR or HIPAA by offloading some of these security tasks to a CASB. Now, this doesn't mean that you don't have to configure things as an administrator, but it's just another tool in our toolkit when getting compliant between our on-prem and cloud deployments. So I'll read this off just so we can get it out of the way. A cloud access security broker is a security solution that acts as an intermediary between users and cloud services to enforce security policies and provide visibility into cloud activity. CASBs address the challenges of securing data in cloud environments, especially in scenarios involving shadow IT. Just saying like, hey, this can enforce us not allowing users to create their own cloud resources, or at least alerting us when they do it. Okay, let's go ahead and do our quiz now. So we are at our custom LMS here. If you want access to this, check the link in the description below. Let's go to our CYSA course. Let's go to our lessons here. We're at domain 1.1.3. We'll scroll down. Let's take our domain quiz. Let me zoom in here. That looks good. So question 1. Which of the following best describes federation and identity and access management? So we're talking federation here. Does it enforce the principle of least privilege? That's not the best description of it. Does it provide visibility and control over user access to the cloud applications? No, that's CASB. We just learned about that. This D describes passwordless authentication. So I'm going to go with A. It enables the user to access resources in one organization using credentials from another organization. Now remember, this is typically the identity provider and the relying party or the service provider that have that shared trust that can do this federation for us. Pause the video if you'd like to read the explanation. Question 2. What is the primary purpose of multi-factor authentication? To allow users access to multiple applications? No, that's single sign-on or federation. Not to eliminate the use of passwords. It's going to be C. To verify a user's identity using 2 or more authentication factors. Pause the video if you'd like to read the explanation. Question 3. What is the primary function of a cloud access security broker, CASB or CASB? So this is going to be the intermediary between users and cloud services enforcing security policies. I always think of it as like that man in the middle, the good man in the middle, the blue team man in the middle that's helping us. Pause the video if you'd like to read the explanation. Question 4. How does single sign-on, SSO, improve the user authentication experience? Is it A, requires users to provide multiple forms? No. It allows users to access multiple applications with a single set of login credentials. That's looking good so far. It eliminates the need for credentials? No. It ensures that privileged accounts are closely monitored? No, that's PAM. So we're going to go with B here. It allows users to access multiple applications with a single set of login credentials. Pause the video if you'd like to read the explanation. Alright, so that is 100%. Let's go, people. I want to thank you for viewing this video. Make sure you like, subscribe, share with your friends, hit that bell for notifications, and I'll see you in the next video when we finish up, hopefully, Domain 1.1.